Hey everyone, what's going on? My name is Kenta from American Hakko Products. And for today's episode of Eye on Hakko, I'm not going to be talking about soldering. No, not soldering. Nope, not soldering. I'm not talking about soldering. Today, I'm going to be talking about torque. What are we talking about today? We're talking about torque. Torque and electric torque drivers. There's a lot of information I'm going to be going over today, so grab a chair, sit back, and make sure you stick around. Today I'm going to be talking about torque and electric torque drivers. And not just any old electric torque driver, not those simple electric torque drivers that we are commonly using. Today I'm going to be talking about intelligent torque drivers. It's a brand new series of electric torque drivers. They're called ATX series of torque drivers, that we have coming out from CHP product line. So that's what I'm going to be talking about today. But before we jump right into talking about the actual ATX torque drivers, let me just give a quick explanation of what CHP, because there may be some of you that may not be familiar with the CHP brand, right, or the product line. So just a couple of minutes about CHP. CHP is our brand of quality assembly tools that we have under the American Hakko company. Okay, and under the CHP brand of quality assembly tools, we have hand tools and we have assembly tools. And under the hand tools, we have different products. As you can see on the image there, we have cutters like our famous CHP 170 cutters. We also have wire strippers, we have pliers, we have manual depaneling tools, we have shears, we also have tweezers. And under the assembly tool line, we have the DPF 300 depaneling machine, and we also have our brush and brushless electric torque drivers as well. And introducing to you all today is a brand new series of intelligent torque drivers. They're called the ATX series, and that will all be under this CHP brand of quality assembly tools, right? All of the service and support is all provided by American Hakko Products. So all of the customer service, the support, the repair services that you get with American Hakko Products, you'll be getting with the CHP brand of products as well. So keep that in mind, something to keep in mind, all right? So that's a little bit about Hakko and CHP. Now, like I said, today I'm going to be talking about the ATX series of electric torque drivers. Torque, I keep talking about torque. So what is torque? So torque, basically, to put it simply, it's a force applied to the lever. So you can see on the image, it's that force being applied to that lever that you see in the image, multiplied by the distance from the lever's fulcrum. The fulcrum is the axis of rotation in which the lever turns. So it's the force being applied to the lever multiplied by the distance from the axis of rotation to the area where the force is being applied. That's what torque is. And you can see here from the image, it says torque causes tension on the fastener, and this tension is what's holding the components together to achieve a proper clamping force, right? Proper torque is also a method of ensuring that the operator or the assembler reaches the proper clamping force on every fastener. Okay, so torque, why is torque important? Because torque is important because torque, using the proper torque value to tighten a fastener is necessary to ensure the quality and safety of the product itself. Again, I'm going to say it again. The proper torque value to tighten a fastener, it's necessary or it's needed to ensure the safety and quality of the final product. That's why applying this, the proper torque is very important. Because if you don't apply the proper amount of torque, if you're not getting consistent results, then that can lead to the assembly becoming, the fastener becoming loose and the assembly becoming loose as well. That can lead to warranty defects, product recalls. Whenever those types of problems occur, that's always an additional unnecessary cost for the manufacturer, and the manufacturers never want that to occur. So that's why you always want to make sure things are being tightened or fastened in place with a proper amount of torque, thus resulting in the proper amount of clamping force holding the two objects in place together. Okay, so that was just a little, basic knowledge about torque. What does torque do? How does it relate to clamping force, which is what actually holds the two objects in place, and why torque drivers are important. Okay, so that's a little bit about torque. Now let's start getting into the specs of the actual spindles or the drivers themselves. And after that, I'll be talking about the specs of the controller as well. So let's start off with the different types of drivers on the new ATX series. We have 3 different torque drivers: the ATX-12, the ATX-30, and the ATX-50. 3 different types of drivers, and for each driver there's a specific amount of torque range and a maximum RPM that the driver operates in. So for example, the ATX-12, it has a torque range of 2.08 inch-pounds to 10.4 inch-pounds. The maximum RPMs on the -12 is up to 2000 RPM. Now you move on to the ATX-30, that has a different range of different torque range. On the ATX-30, the torque range moves to 5.2 inch-pounds all the way up to 26.03, just over 26 inch-pounds. And the maximum RPM on the ATX-30 is now up to 1200 RPMs. And now when you move on to the ATX-50, another different torque range. It goes from 8.87 inch-pounds all the way up to 43.39 inch-pounds, almost 43.4 inch-pounds on the ATX-50. And the RPM on the ATX-50 is now maximum of 700 RPMs. So that's just basic specs on the drivers themselves. The drivers themselves, let's take a closer look at it. The handles obviously are ESD safe handles. There's a lever on the handpiece. So this is what the torque driver looks like, right? There's a lever on the other side. There's a button. This button, when you turn it on, it's for reverse action. When it's not illuminated, it's for forward clockwise. When it's illuminated, it's for counterclockwise. Okay. There's a nice grip here, and there's also LED indicator lights, 2 on one here, one on the other side. So there's 2 indicator lights, and they illuminate either green, yellow, or red. And by default, green is signifying that it was a good joint, yellow meaning that the driver is ready, and red indicating that it's not a good, it wasn't a good joint. And I'll show you here later on, but by using the controller, you can actually customize what those lights mean depending on how you want it. You can program it differently. There's also light down here at the bottom. As you can see, it illuminates. So it gives you a nice working space when you're working on a particular application. Maybe it's dark, then you can get some nice lighting on that joint. And again, that lighting, you can also go into the controller and control it anywhere from 0%, turn it off, to 100% maximum illumination. Okay, and this is where you attach. This is a 1/4 inch hex bit. You pull up, and you can remove the actual screw head. So that's a little bit about the driver. Let's stay on the driver just for a minute, just for a quick minute longer. So this is, the overall driver, right? And the difference between a driver, an intelligent torque driver like this, and a simpler brush and brushless clutch driver is that these drivers, they have, they obviously have more electronic components inside, but these ones have an encoder. It works. They have a servo motor inside. Excuse me, servo motor inside. A servo motor, right? And there's also an encoder in there, and there's also a transducer in the handpiece as well. So the transducer is controlling and monitoring the amount of torque, and the encoder is what allowing to monitor and control the angle or the amount of rotation that the spindle is seeing. So that's what's that's the big difference between these drivers and a more simpler brushless clutch type of drivers that we also have available under the CHP assembly tools. Okay, so that was general information about these intelligent torque drivers. Now, because these drivers have the encoders and the transducers built into the handpiece, what you can control, you can do torque and angle control and monitor with torque and angle, right? That's the difference. Now, because they have encoders and transducers built into the driver, the drivers can also feed back that information to the controller, and you're able to, not only monitor, see the results of a good joint, bad joint, you're able to record and export all that information as well. That's another big difference between a regular brushless driver versus these transducerized intelligent torque controllers and drivers. Okay, so those are the drivers themselves. By the way, for today's webinar, I have a ATX-12 to my left and an ATX-30 to my right, just so you know. Okay, so that was some information about the torque drivers themselves. Let's talk a little bit about the specs on the torque controllers. We have two different types of controllers available. One is called the ATX-P1 and one is called the ATX-P2. What is the difference? The difference is that the P1 is a single port controller and the -P2 is our dual port controller. Okay, so we have both a single or dual port options available when it comes to the ATX torque controllers. Now, just to go over some basic specs or information about the controller, is that there's a nice touchscreen. It's a 10-inch touchscreen display that you can program different user profiles. There's even a password protection feature that you can set up for up to 5 different users. Plus you get the admin user. There's built-in Ethernet capabilities already to the controller, whereas other transducerized drivers and controllers, other ones, the Ethernet capability may be an add-on where you have to pay an additional fee to get that feature. Ours is already included with whichever the P1 or the P2, the Ethernet capability is already included with the controller, so there's no additional cost. For one single tool, you can create up to 500 different parameters that you can store in the controller. I think that's 500 more than enough, but 500 you can do per tool. So if you're using 2 drivers, like the one I'm using on the P2 controller, that's 500 per tool. So that's a total of 1,000 different parameters that you can program into the controller. Right? There's also sequence programming that you can use. You can use that for when you're using multi-bolt program fastening, or there's also results and rundown graphing that you have access to. There's data collection and reporting from the controller. There's an HDMI port. There's automatic tool recognition. So once you attach a ATX-12, for example, an ATX-30, for example, on this my setup that I have here, the controller already automatically recognizes that this one is a 12 and this one is a 30. It does that automatic tool recognition. There's also the lever sensitivity control that you have on the controller. There's 8 in total, 8 inputs and 8 outputs that you have access to, so that you can connect different digital inputs and outputs to the controller. There's also a RS-232 connection that you have, so you can attach like a barcode scanner, right? You attach a barcode scanner using the RS-232. You scan it, and you can program it so that it automatically calls out a particular parameter or sequence for you. You can use that way. There's also another RS-458 connection that you can use to say you can connect it to like a PLC connection, external PLC connection if you wanted to. HDMI connection, I already mentioned that. And there's also a USB port on the bottom of the controller. You can use that to attach a USB drive, and you can not only export and import different parameters and sequences from one controller to the next, but you can export the different results and the different reports that you have access to through the controller. You can export it to the USB drive, and it'll save it as a CSV file. So that's, I know it was a lot of information, all that specs, but that's just in a nutshell, basic information about the spindles or the drivers, the different drivers that we have available, and the controller itself. Again, we have a single port version available and a dual port version available. Ethernet capability already built in to the controllers themselves. Okay. So now that we got that taken care of, I want to move on and talk about the actual operation and get into the demo of how to use these intelligent torque drivers and controllers. So let's get into that, shall we? This is the main home screen of the ATX Torque Controller. You can see there's different icons. There's a total of 8 icons altogether, right? And if you go into the different icons, you have access and control over different things. I won't get into every single one of them. I can show you some of them, the main important ones today to keep this short, but I can go over what each of those do. For example, parameters, that's your parameters, sequence, sources, and results. That's what you're mainly going to be using when you're using these tools or when you're using the controller. Parameter is the menu you're going to be going into to create different parameters or different strategies for a specific fastener and application. Sequence you can use for different multi-bolt program fastening. You can use that sequence feature. Sources is where you can go into and call out whatever parameter or sequence that you want to have used on the specific tool, tool 1 and tool 2. And the results. The results is where you're able to see the individual results for every single fastener application that you have just worked on. You'll be able to see the results. Down here below are more like your system or controller settings. Controller, you have, for example, you go into controller, you can change your language, you can control your default angle and torque units. You can set password controls if you go into the permissions, factory resets, all that good stuff within the control settings, right? Go back, you go into the tool. I go into the tool, there's tool 1 and tool 2. Again, it automatically recognizes the model, the serial number, the max speed, the max torque allowed. There's even a counter, so you can set the maximum amount of joints that you allow on this particular driver, and then whenever it exceeds that amount, then it gives you a warning. You can do that service reminder on or off, right? Same thing you can do in tool 2 if you have a 2-port station. But if you keep up on the tab above, there's different tool settings and work light brightness. That's where you can adjust the brightness of the lights that I was talking about earlier. Anywhere from 0 is obviously off and 100% is full on, right? You have that control. For tool 2, right now it's at 0, but I can, for example, change that however way you want it to. Okay. Also, you have the lever start. That's where your sensitivity for your lever start. You have the same thing for your push start. That's where you control the sensitivity for your lever and push to start actions. Okay. LED light settings. This is, still staying with the drivers themselves. I told you the green, yellow, and red indicator lights. The green, yellow, and red indicator lights. For each of those indicator lights, you could go in and assign what each of those indicator lights mean, for example. So right now, the green indicator light says tightening okay. Yellow indicator means that it's ready. Red indicator means that tightening not okay. So you can go into each one of them, and if I wanted to, go to green, not in use, right? You can do that. You can customize it any way that you want it to. You can do that for, again, tool 1 and tool 2 when you're using a 2-port system like the ATX P2 that I have set up here. Okay, so those are just some of the controls that you have. Again, when you go into the controller gives you access to different controls of the actual controller. Tool gives you different controls when you're talking about the drivers themselves. Okay, now let's get into how to actually get started and program and use these tools. Just some basic operation and a quick demo of how to use these tools. So the first thing you want to do is, how do you create a parameter or a profile or a strategy? You go into parameters. This is where you create different parameters. You can see already I have 6 different parameters already programmed under tool 1, right? And if I hit tool 2, again, I have another 6 different parameters that I have created and programmed for tool 2, right? So tool 1, different ones, tool 2, different ones, okay? Now I'm gonna stay on tool 1. So how do you create a brand new, I'm gonna go ahead and show you how to create a brand new parameter. Easy. There's this create new icon, right? It's like a page with a plus sign on it. That means create new. You hit that. It'll give you a pop-up a new window, and it says create parameter. So the first thing it'll ask you to do is to input a title. ID 7. So let's just, for the sake of it, so I'm gonna name it 7.0 inch pounds, right? Enter. And then the tightening torque, I'm gonna put 7.0. Okay. Now, as long as you know the target torque that you need, there's a very easy way you can get started on creating a parameter. Just use this quick start method, keep that on, hit confirm, wait for it to create a parameter for you. And what it did is, now the tool has just created a simple parameter under under the information that you just put in. 7.0 inch pounds is the final tightening torque that I'm trying to reach. You see, 7.0. And then what the controller now did was, for the start, run down, pre-tightening, and tightening stages, it has now input, it's kind of like a guide to get you started off with. It already put you some information in there for you, so you can get started with this parameter right away. It's a simple, very simple way to get you started off right away. It's like having a pre-programmed profile already in there for you, depending on the final torque value that you want to use. All you have to know is the final target torque value that you want to use for that particular fastener and that assembly, and you can get started right away. Now, once you do that, there's also, as you can see, you can customize it however way you want it to. For example, you go into the tightening settings, right? And under the start, right now I have it set at 90-degree angle at a speed of 80 RPMs, right? So that means that it's gonna rotate for 90 degrees at a speed of RPM. I can go in and change that if I want. So instead of 90, I can change that to 360 at a speed of 50 RPM. So now what it's doing, it's going to go 360 degrees. So one full revolution, it's going to move at a speed of 50 RPMs, right? Max torque is 7, min torque is 0. And on the next stage, the rundown stage, now it's going to speed up a little bit, up to a speed of from 50 RPMs to 490 RPMs, and the target not to go over 1.75. Now this torque value is about 25% of what your final target torque that you have input is going to be. So in my case, I have set at, what did I put, 7 inch-pounds. So 25% of 7 inch-pounds is 1.75. Right, so that's what that is. And then it's also going to be taking a look at the max torque, 7, and the maximum angle, 9600 degrees of rotation. It can't go over that. You can also put a minimum angle if you choose to. You can, like I said, you can customize it any way you want to. You go into the pre-tightening, again at 1.7, speed now it's going to slow down to 150 RPM. So this is where it goes to the rundown stage, and then now it's slowing down. And here, this is your final tightening stage where the torque target is 7 inch-pounds. The speed slows it down. We bring it down even more, slow it down from 150 to 100 RPM, and the max torque by the quick start default setting is 7.35, and the minimum is 5.6. Again, you can go ahead and go in there and change it to, like, say 7.5, and instead of 5.6 I can change that to 6.5. Right, again, you have that capability to go into the start, rundown, pre-tightening, and tightening stages and customize it however way that you want it to, depending on the application or the process, the assembly that you're working on. But again, and at the end, make sure you save it. And there it is, 7 inch-pounds. That is a brand new parameter I created for tool 1 using the quick start method, and going into each of the different tabs, start, rundown, pre-tightening, tightening, and just a little bit being able to customize it however way that I choose to. Okay. Now there's also another way that you can create a parameter. I'll do that in, say, tool 2, for example. So tool 2, the way you create it is the same. Create new, and you name it. I'll name this again 7.0 inch-pounds. Oh, whoops. Yes. Hit enter. Again, I'm going to hit 7 here. But the only difference now, I'm going to take the quick start off. Hit confirm. Now, what you can do now is you can select different strategies. Instead of a standard, maybe I want to do self-defined, right? Where you have a selection of up to 1, 2, 3, 4, 5, 6 different stages or steps that you can customize each of the different steps however way that you want it to. So that's called self-defined. There's also enhanced that you can do, and in the enhanced stage you have access to only the tightening stage, right? And in the pre-position stage, if you go into tightening settings, you have access to only the start and rundown stages of the tightening sequence, or the tightening settings, right? So within the parameter, you have standard, enhanced, pre-position, and self-defined. You have those 4 different types of strategies that you can choose to work with. But in most cases, I think most of the people are going to be using either standard, or they're going to want to customize it in a way that you're going to be using self-defined, right? But just know that you have 4 different strategies that you can work off of, right? Okay, so I'm going to go back to standard, and that's, that'll just save my parameter under tool 2 7-inch-pound final torque settings. Okay, so again, that's how you would go into the parameters and create a brand new parameter under the parameter settings. Okay, so that's how you get things started off right away. Go into the parameters. First of all, figure out the torque value. That's very important to know. Figure out what the final tightening torque value is. Once you have that information, go into the parameters, create new, pick a name for it, enter the final target torque value, and do a quick start, and that'll get you started right away. Okay. Now, let's go into the sequence. I'll talk about the sequence now. The sequence will allow you to use the combine, like the different parameters, so that you can use it for multi-tool program fastening. So what I mean by that, I'll show you here, is if I go into the sequence, then you can see I have different sequences already put in here. You know, I have 6 sequences already created, and for each sequence, there's different things I have programmed in there. For example, sequence number 6, I'm using tool 1, and I have it named tool 1 5.0 8.0 sequence. So I go into there, and what does it mean? It means that for this particular sequence, I'm using tool 1. The parameter I'm using first is 5-inch-pounds, and I'm doing 3 screws. And after that, maybe there's a different part of the product that I'm assembling that I need to fasten at a different torque value, but still using the same tool. So that's what I'm doing. Using the same tool, different torque value, moving from 5-inch-pounds to 8-inch-pounds, and I'm doing another set of 3 screws, right? So that's my sequence, which I have named tool 1 5.0 8.0 sequence, right? So that's under the sequence. So that was this one. There's also different combinations that you can do, right? For example, when it says tool 1, I'm only using 1 tool. When it says tool 2, I'm only using 1 tool. But you also see some of them, it says mix, right? If I go into this one, ID number 4, mix, I have it named as 2 tool build. Let's take a look at what that can do. If I take a look at that sequence, as you can see, I have 2 different tools, tool 1 and tool 2, that I'm using now, right? So first 6 screws, right? So first set of 3, I'm using tool 1 at 5-inch-pounds, and then I'm moving over to a different part of the product. I'm still using tool 1, and I'm doing another 3 screws at 8-inch-pounds. But then maybe I'm done with the inside of the product, and I'm moving over to the outer cover of the final assembly product. And for the final assembly of screwing down the cover of the product, maybe I have to use tool 2 at a higher torque value. And for that torque value, I have to use tool 2 at 15-inch-pounds, and I have to do another set of 3 screws, right? You can do that. You can not only do that with, you can use a sequence with 1 tool, but you also use it with 2 tools. That's what you can do with a 2-port system. That's what's so great when using these 2-port systems. You don't have to have 2 different single-port stations on your workbench. You can use 1 controller, right? You can have 2 spindles attached, different torque values, and you can use the sequence function to make multi-bolt fastening sequences. It'll allow you to do that on a 2-port system like we have here. So let's just go ahead and get into the demo, shall we? So I already have them built in. So what I'm going to do now is go into the sources. Again, sources is where you call out the different parameters or the different sequences that you want to use for that fastener or that assembly, right? So right now, up at the top, if you see at the top of the tab, I have the option to to hit single tool, dual tool alternation, or dual tool synchronization. I'll just talk briefly about that, and I'll show you an example later on. But single tool, what that basically means is the controller is controlling the tool 1 and tool 2 independently, right? So you can use both tools at the same time, different torque values, it doesn't matter. You can use that at the same time, or one or the other, it doesn't matter. It's a single tool control, right? Now, what dual tool alternation means that, I'll show you that in a minute, but you're using, say, tool 1 for a set of screws, and later on you're using tool 2 for another set of screws. It's dual tool alternation. So tool 1 and then tool 2. You can do that. And then the last one is dual tool synchronization, where you have to use two tools, two spindles, both simultaneously synchronized, all at the same time. That's dual tool synchronization. That can be used for, maybe you have a assembly and you have to put on a final cover piece, and maybe you have to fasten down the all four corners all at the same time. You can use dual tool synchronization. You can use 4 P2 controllers and program it in a way that they all come down 4 joints and fasten all 4 locations all at the same time. You can do that by using dual tool synchronization. So those are just a brief explanation of what single tool, dual tool alternation, and dual tool synchronization mean. Okay, so going back to the sources. Sorry, maybe I got a little bit sidetracked there, but going back to the sources, tool 1 right now have parameter title calling out 5 inch-pounds. I'm doing 3 screws at this parameter, and tool 2 I have it set up at parameter 12 inch-pounds and another set of screws. Again, they're working independently because I have it set to single tool, right? So once I go into the results, these are your results page. Parameter is 5 inch-pounds, target torque is 5, and the number, the quantity I'm looking for is 3, right? So I'm gonna grab tool 1 and come down on it. There's 1, you saw that green light. Now it's yellow, means that I'm ready to move on to the next fastener. And if we take a look at the controller, it also gives you, 1 out of 3. I did 1 out of 3. Target torque was 5. The actual applied torque, or the torque being applied, was 5.026. Well within the window that we have it programmed to. The angle that we saw, total angle, was 2150, and the tightening angle was 7 degrees. Okay, so it gives you that information. And so this is just basic way of using it. Doing it again and one more time. There. So that just that's a very basic way to where you can use these torque drivers by calling out a simple parameter, right? If there was a error or you tightened it, there was too much torque being applied, it exceeded the amount of torque being applied, then you'll get a red indicator light on, not only on the controller, but you also get it on the driver, but you also get it on the controller as well, right? Okay, so let's go back to the sources because I want to show you something that's very useful that I talked about. So if you go back to the sources, I'm still on single tool mode, but I go into the menu, and you can see it's parameters. These are all the parameters that I have set up. But if I hit the tab of the sequence, I can call out the different sequences that I have already created. So you can see I have tool 1, 5.0, 8.0 sequence. I call that out. That gets called out into tool 1, and then now I go back to the results. Tool 1, 5.0, 8.0 sequence. That's the sequence I have created before, where I'm doing 3 screws at 5 inch-pounds and another 3 screws afterwards at 8 inch-pounds. So for a total of 6. So the first one I have set to 3, 0 out of 3 right there. Target torque is 5. And come down on it. There's 1. Good, green light. There's 2. Another green light. And there's 3. So I'm done with the first 3 screws that I did at 5 inch-pounds. And you'll notice that the target torque automatically switched over to 8 inch-pounds, and the parameter now I'm using is 8 inch-pounds. So that's a example of how I'm using the sequence mode on these tools. Oh, sorry, now I gotta back one up real quick. And once I'm done with the entire sequence, then it'll go back and I'm ready to start over from the first set of screws that I have set at 5 inch-pounds. So that's one way you can use the sequence function on these intelligent torque drivers and controllers. Okay, very useful in cases where you have a product, right, and you're assembling a product and you have different torque values all within the same product. One you have to do at 5 inch-pounds. Another area you have to do at 8 inch-pounds. Another area you have to do at 2 inch-pounds. You can create a sequence so you can still use the same tool, and the controller will automatically go switch from 5, 8, and 2 just by programming it the way you want it to by using the controller and the sequence function. Okay. Another useful way you can use this sequence or sequence method is the dual tool alternation that I want to show you. So right now it's on single tool. So first I'm going to switch it to dual tool alternation. Dual tool alternation, I mentioned before that you're allowed to use 2 tools, but one's going to go after another, right? So just as a reminder, what 2-tool build was. If I go into sequence, take a look at 2-tool build. It was 3 steps. First one is using tool 1 at 5 inch-pounds for 3 screws. The second step is using tool 1 at 8 inch-pounds for another 3 screws. And the third step is using tool 2 at 15 inch-pounds for another, for the final 3 sets of screws. Okay, so that's the sequence for 2-tool build. Okay. Going back to sources, I have that called out, 2-tool build. So for a total of 9 screws. All right, cool. So I go back to results. So a little bit different in the display here that you saw before, but still basic same thing. You got tool 1 and tool 2, but you'll notice by looking at the screen, you'll see this message here. It says wait for tool 2, right? So even if I try to use tool 2, because of the way I have the sequence programmed with the controller, and I'm calling out the 2-tool build sequence, even though I try to use tool 2 first, and I go down on it like that, it won't allow me to. And it'll also give me a warning message on display. It says incorrect parameter setting, tightening prohibited. That's because for this particular sequence that I'm calling out, the first step is what? I have to use tool 1 at 5 inch-pounds, right? So let me go ahead and continue with this demo for this sequence. So I'm going to go ahead and, so 5 inch-pounds, 1, there's 2, and there's 3, and now I switched over from 5 inch-pounds to 8 inch-pounds, but still I'm using the tool 1. There it is, 1, 2, and 3. Now within my sequence, I'm done using tool 1, so that waiting message switched over from tool 2, and now you can see it on tool 1. And now even though, you know, I press the lever on tool 1, there's no action that's going to be applied to it. I got to use tool 2 now. That's the whole point of it, right? So I'm going to grab tool 2, and here we go. Before I couldn't use it, remember, but now, there you go, tool 2. Green light. Another green light. So I'm done with the nine screws, and now I can go ahead and repeat that process for that whatever application that I was working on. I'm ready to start over again using this particular sequence. So that again, that was just a quick demonstration of how you can create sequences, how you can use different sequences. You can use it with a single tool operation, or that one didn't work because I'm still in that sequence. So I go back to sources. I'm going to switch it back to from dual tool alternation to single tool, right? And then it'll allow me to use tool number 2. Okay. So that's how you use a sequence. That's how you create it. Not only create a sequence, but that's just some examples on how you can make use of a sequence. It's for when you're using, you know, multiple different types of bolts or screws, and they have different torque values on it. You can program the drivers so that they work only the way that you want it to. Okay. If we go back to the results, you can see that the results page gives you obviously the results of the tightening that you just worked on. Those are the results, but if you go into the actual curve, there's also a curve tab, and it's also going to give you the graphical curve of what that final torque tightening results were, right? It'll give you that graphical image. So you can get that as well under the results page. Okay, now the reports, if you go into the reports, it's going to give you all of the reports of the tightening sequences and parameters that you've worked on throughout the history of the machine, right? So you can see all of these are my different results. You get the date and time, what tool you used, the final angle, the tightening angle, the final torque, and the status of whether it was okay or not okay. All of that information is laid out under the reports page. You also get a tab for the error. You can take a look at all the different error messages that popped up on your screen, maybe for excess torque or excess angle. You also get the warnings for all the different warnings that popped up on the screen. That's also there. Oh, and going back to the production report, you can also, I mentioned there's a USB port on the controller itself. You can attach a USB drive, and you can export that information onto a USB drive, and you'll be able to save that information as a CSV file. So you can save and record all that information as well. Okay, another useful feature when you're talking about using these smart or intelligent electric torque drivers, you're able to not only control and monitor the drivers by torque and angle, but you're also able to record and do the data logging capability through the controller by saving it onto a USB drive. So that's, in a nutshell, that's just the basic information of what these controllers can do. There's all sorts of, how would I call it? A lot more customization that you can do within the controller. Like I said, you can make a self-define, and you can customize the driver and the fastening job any way that you wanted to. You can control the tool settings, the lighting, the LED lighting, the buttons of the reverse clockwise, counterclockwise. You could customize all that. But I'm just going over just some of the basics, how to get started when you first set up the ATX Intelligent Torque Controllers, how to set up these drivers and the controllers. So still, I think that was a lot of information that I went over today. I hope it was some useful information to help everyone get to know more about our new series of intelligent torque drivers and controllers. Again, they're called the new ATX series from CHP, Intelligent Torque Controllers and Intelligent Torque Drivers. They are now available for purchase. If there's any more information that you would like to know about these new series of ATX torque drivers, you can visit our website at www.HakkoUSA.com. You'll find information about our torque drivers there, or you can give us a call. It's 1-800-88-HAKKO, and you can talk to one of our customer service representative. Yes, we still have live person customer service representatives, not automatic robots that assist you. We have people that are ready to help you out with any kind of questions that you may have about any one of our products, not only the ATX, but also Hakko as well, Hakko products as well. So again, I hope I was able to clear up some information about the driver, about the controller. I hope I was able to give a good demo on how to use these drivers, when to use different sequences, how you can use different sequences with these two drivers, how you can use a two-port system, when a two-port system, how a two-port system is very useful when you're making a final assembly on a particular product. I hope I was able to show all of you guys just a quick introduction into our very fine new ATX series of drivers, all right? And again, we'll keep these webinars, try to keep them going every month or every other month, as often as I can, just to keep you guys up to date on the latest information and the latest products that we'll be having from American Hakko products, because this ain't it. This ain't it. Oh no, this ain't it. We went over the 971 last month, and now we have the ATX drivers that we're doing this month. And believe me, this ain't it for this year. We're still gonna have some more products coming out. It's a surprise. It's a surprise, all right? So what I always say, remember, keep your eye on Hakko. That's what I always mean when I say, remember, keep your eye on Hakko, because this ain't it. We're still gonna have new products coming out, so keep your eye on Hakko, man. Always, always, always remember, keep your eye on Hakko. Thanks.